All right, class, welcome back. We got one more week of learning one new concept that's not as bad, I think, and then we got a test, and that's pretty much it. We're almost there. We're on the home stretch in terms of finishing the year. So we're going to start with a review of what we did last class. I feel like a lot of people struggle with it, and that's understandable because it's a hard concept. So I'm going to do two problems that are from an additional worksheet that I have for you, and then I'm going to have you do a couple more practice problems on that, and then there'll be 5 problems on the new concepts. So, all right, so let's get into it here. Okay, so the first one, you have to look here, and you have to think about what your u is going to be, right? So you want to look in the parentheses is what you're looking at, right? So x squared plus 1 will be my u, and then 2x dx is going to be my du. All right, so let's do that right now. All right, so if you take u and we say u equals x squared plus 1, then du equals 2x dx. All right, now we see that we have 4 here, and that creates an issue. So what I'm going to do is I'm going to rewrite it, and I'm going to say 1/2 times 4, because that'll get me back to 2, right? So 1/2 times 4x, and then I have the rest of my integral here. And then the other thing you have to remember that is if you put that 1/2 there, then you have to do the opposite outside. So I'm going to put a 2 outside. All right, so now I have 2x squared plus 1 to the 5th dx. All right. So at this point, I have this set up, right? Because remember, we're trying to figure out what u and du are, and that will account for everything here. So now I have 2 times u to the 5th, right? That becomes u du. All right, so that, once we go integrate, now we have u to the 6th over 6, right? And that's really going to be like 2 divided by 6 is 1/3, and then the u becomes x squared plus 1. So x squared plus 1 to the 6th, and we're not evaluating any numbers here. This is actually an infinite integral here, or indefinite. So we're just going to put plus c, and that finishes that problem. Okay? So we have 1/3 x squared plus 1 to the 6th plus c. But you can see how we successfully use u and du to solve this one. Okay, next problem. So next one's a little tougher, but similar thing, right? We said that if we have a square root or parentheses or something in the denominator, which this is in the denominator and a square root, then what's inside here is going to become u. So u is equal to x squared plus 4, right? And then du is going to be 2x dx. All right, so we can already see the 2x dx here, okay? So that is really useful, right? And then we're going to look here, and then we're going to replace this with u. So the way I'm going to write this is 0 to 2, and I'm going to have du up here, and then I have square root of u. Okay, now since that's in the denominator, you would call that u to the 1/2, but I'm going to call it, or sorry, since it's in the denominator, it would be u to the negative 1/2. So I'm going to rewrite this in a way that I can use u to the negative 1/2 du. And we got our 0 to 2, but we're not going to worry about that until we integrate. All right, so now we go to integrate. Remember, you got to add 1, so it's going to become u to the 1/2 divided by 1/2, which is really like 2, right? So we're going to get 2u to the 1/2. And now we're going to go ahead and put this back in, right? So what we really have is 2 times, what was our, x squared plus 4, sorry. X squared plus 4 to the 1/2, okay? Now, we're going to rewrite this so it's a little easier to input the numbers. because we still got to evaluate our 2 and our 0. So we're going to rewrite this as 2 square root, since it's the 1/2, x squared plus 4. And now we can input 2 and 0. Right, so you can see as you input 2, you're going to get 2 squared plus 4, and then you're going to minus, and you're going to get, here you're going to get 0 squared plus 4. Okay, so that's going to become 2 square root of 8 minus 2 times, well, square root of 4 is just 2, so minus 2 times 2. All right, now one thing to simplify here is this is really square root of 4 times square root of 2, and then this becomes 2, so it's really, so we're saying 2 times 2 square root of 2, right, minus 4. So our final answer here is 4 square root of 2 minus 4, right? And again, like, if you got to right here, you know, you could use the calculator from here, and that would be fine. Excuse me, but this is how you want to write your final answer. Okay? So, that was the review. Now we're going to move on to one new concept, and this is pretty easy, I think, in terms of what you have to do. So, if you look at this image is a little bit hard to see, but you have one function here that's g of x, then you have this other one called f of x. And if we wanted to find the area between these two curves, okay, what we can really do is just subtract, because if you think about it, right, the area below this curve, g of x, is going to be represented by this, right? Or sorry, f of x, right? And then g of x is up here. So the way you would do this is, if you want to get from a to b, you would say from a to b, and you would start with the top one. You say g of x dx. And you can either put them in one integral, as you'll see on the worksheet, has them in one integral. I don't know, I like to put them in two integrals, just a little easier to work with, I think, or to conceptualize. So the top one gets or the bottom one gets subtracted from the top one, right? So let's do an example of that. All right, so if you see here, this says we got two functions here, and I graphed it in Desmos just to kind of show us. So we have two functions here, and we got to go from 0 to 1. So the first thing to notice is like kind of visualize what the bounded area would look like. So it would be from 0 to 1, right? And then we would shade in everything here. So really the bounded area is like this area here, right? That's what we're trying to figure out. Okay, so the x squared plus 2 is on top, and the negative x is on bottom. So the way we're going to set this up, and we're going from 0 to 1, is we're going to say 0 to 1, x squared plus 2 dx minus 0 to 1, negative x dx. Okay, so this is pretty easy to integrate. So you can do this one, you can do this one by hand, but I will let you guys use a calculator for the more complicated ones. I'll show you in the next example. So that would be, so you got this to integrate, and then you have, or this is already integrated, we're going to input the numbers, and then you have negative x squared divided by 2 from 0 to 1, okay? So at this point, we're going to say 1/3. We're going to input 1 cubed is, just 1 over 3 plus 2, and then minus, and then the 1 over 2, right, is a negative 1/2. All right, so really that's plus. But we're just going to, from here you could just add this together, but if you want to add it with by hand, then you would want to go like this. So this is going to become plus, and this is like 1/2. Well, you're just getting the denominator to be the same, and then you would get 17 over 6 as your answer. Okay, so the important thing is that whichever function is the top one gets, you subtract the bottom one from the top, and you should get a positive answer when you do that. Okay, so we're going to go on to one more example, and then the nice thing is that the worksheet has worked out solutions, so you can really check your work. I think that would be helpful as well. All right, so this one just says like find the area of the region bounded by the graphs of x and 2 minus x squared. So what you really want to do here is you want to look at this area, right? And so we're trying to find that shaded area from -2 to 1. And so the first thing to notice is that we're looking at from x equals -2 to x equals 1, since they didn't give us that. All right. And now we're going to set up our functions, right? So our top one is our parabola. So we're going to have -2 to 1, and that's going to be 2 minus x squared dx. And then we're going to have minus -2 to 1, and that's going to be x dx. Okay, now this one's not super hard, but once they get a little more tricky, you'll see in the homework. From here on, you can use your calculator. What I'm interested in is that you set it up and you know how to do it. And so I would go ahead and go to my calculator, and I'm going to say menu, calculus, integral, -2 to 1, 2 minus x squared dx. All right, and then I'm going to get an answer. And then, so that's my first part, right? Then I'm going to go do that one more time. Go to integral, -2 to 1, x dx. All right, so then I get 3 and -3 over 2. All right, so now I'm going to say, well, that's 3 minus -3 over 2. And again, if you want to add it by hand from here, well, that's like 6 over 2 plus 3 over 2, which will leave you with 9/2, or 4.5. Okay, so this is pretty easy. That's why I'm only going to do 2 examples here. When I see you in class, if you have questions about the homework, then you can look at we can look at those problems together. So, all right, see you all in class on Wednesday.